Now let's do one more example. Discuss the continuity of the function f defined by f of x is equal to 1 upon x, where x is not equal to 0. And now if x is not equal to 0, then in that case, limit x approaches c, f of x is equal to limit x approaches c 1 upon x. And when x approaches c, then the value of x is also equal to c. So that means 1 upon x is now equal to 1 upon c. And what is the value of the function at point c? The value of the function f of x at point c, or f of c, is equal to 1 upon c. And again here, the limit of the function at the point c is equal to the value of the function at the point c. That means the given function f defined by f of x equal to 1 upon x, where x is not equal to 0, is a continuous function. Now let's solve one more question. Discuss the continuity of the function f defined by f of x is equal to x plus 2 if x is less than or equal to 1, and f of x is equal to x minus 2 if x is greater than 1. Now if you look carefully at the given function, then you can see that x is defined for all values of x if x is a real number, and the behavior or the value of the function f of x changes when the value of x changes from less than 1 to greater than 1. So that means in order to check the continuity of the function f, we can divide the domain of this function into three cases. In our first case, we shall check continuity of the function for x less than 1, and the other case will check the continuity of the function at x equal to 1, and the third case will be to check the continuity of the function if x is greater than 1. So now let's check the first case. In the first case, let's check the continuity of the function at point c, where point c is less than 1. And now if c is less than 1, then as per the definition of the function, if x is less than or equal to 1, then f of x is equal to x plus 2. And that means in this case, f of c is equal to c plus 2. And what will be the limit of this function at the point c, where c is less than 1? Now limit x approaches c, f of x is equal to limit x approaches c, x plus 2, and which is finally equal to c plus 2. So here the value of the function and the limit of the function at the point c, where point c is less than 1, are both equal. And as per the definition of continuous function, if the value of the function and the limit of the function at a given point are equal, then that function is continuous at that point. So that means the given function f is a continuous function for all real values of x less than 1. And now let's check the continuity of the function if c is greater than 1. Now if x is greater than 1, then f of x is equal to x minus 2, which means fc is equal to c minus 2. And now let's find out the limit of the function at x equal to c, where c is greater than 1. Now limit x approaches c, f of x is equal to limit x approaches c x minus 2, and which is equal to c minus 2, and which means the limit of the function at the point c and the value of the function at the point c are again both equal. So that means the function f is continuous at all points where x is greater than 1. And in the third case, c is equal to 1. And now to find the limit of the function at the point c equal to 1. Now the behavior or the values of the function f of x will be different for c greater than 1 and c less than 1. So in this case, let's first find out its left hand limit. Now the left hand limit of this function is limit x approaches 1 from the left hand side f of x, and which is equal to, and now if x is less than 1, then f of x is equal to x plus 2. So this limit becomes limit x approaches 1 from the left hand side x plus 2, and which is equal to 1 plus 2 or 3. And in the same manner, let's find out its right hand limit at x equal to 1. Now limit x approaches 1 from the right hand side f of x is equal to, now as x approaches 1 from the right hand side or x greater than 1, then f of x is equal to x minus 2. Now this expression can also be written as limit x approaches 1 from the right hand side x minus 2, and which is equal to 1 minus 2 or minus 1. So here clearly you can see the left hand limit and the right hand limit are not same. So that means the limit of the function at the point x equal to 1 doesn't exist. So that means the function f of x is not a continuous function at the point x equal to 1. But in this case, you have also noticed one thing, that if x is less than 1 or if x is greater than 1, then the given function f of x is a continuous function. But at the point x equal to 1, it is discontinuous. So that means x equal to 1 is the only point of discontinuity for the given function f, and which you can also see by drawing the graph of this function. So you can see, and if we draw the graph of this function, you can clearly see that if x is less than 1, then this function is continuous, and if x is greater than 1, still this function is continuous because we get a straight line in both cases. But at the point x equal to 1, the given function is a discontinuous function, or x equal to 1 is the point of discontinuity for the given function f of x.